My name is Lisa Levin. I am a professor, now emerita, meaning I just retired, at the Scripps Institution of Oceanography at the University of California, San Diego. And I'm presently doing research on the deep ocean and working on the biology of the seafloor, how it's affected by climate change, how it's affected by human disturbances. And I'm particularly interested in bringing our science to policymakers who are making decisions about the ocean. Well, the deep sea is most of the ocean. It's all of the ocean below 200 meters water depth, or about 600 feet. And we've mapped about 20% of the seafloor, for example, but we haven't really explored all the marine life that lives there. I would say, we've described only a small fraction of the species that live in the deep sea. And we certainly haven't even seen all the different types of habitats and ecosystems that are there. It turns out that the deep sea stores a lot of the carbon on this planet. There's 50 times more carbon dioxide stored in the ocean than there is in the air, and most of that ends up in the deep ocean, which, as I mentioned, is most of the ocean. And so people are interested in ways to put even more carbon dioxide, which is the greenhouse gas that's causing a lot of our global warming, not all of it, but a lot of it. And they want to deposit it in various ways into the deep ocean, believing that because there's already so much carbon down there, that it's a logical place to put extra carbon. One of these is called ocean fertilization, where iron is added to the surface waters. It enhances photosynthesis by phytoplankton. Photosynthesis draws carbon dioxide out of the ocean, and that means the ocean can hold more and draw more out of the air. So when those phytoplankton grow and die, they sink, or they're eaten by things that then poop them out. But in any way, they make their way down into the deep waters of the ocean, where the carbon is out of circulation and kept away from the air for varying lengths of time, depending on where on the planet you are and how deep. And another one that's gaining interest is what I would call macroalgal culture and sinking. We already grow seaweed, which are macroalgae, for aquaculture, and people eat those, but there's some interest in creating massive seaweed farms that, again, draw carbon dioxide out of the seawater for photosynthesis. And then there's a plan to sink the algae into the deep sea, where it's kept, where that carbon would be kept out of circulation for up to hundreds of years, or maybe even 1,000 years, depending on how deep it went and where. If you were to have massive amounts of algal growth, which we do in our coastal zones sometimes with excess nutrients, we know that can lead to loss of oxygen in the midwaters. That's because the algae decay, and the microbes that cause that decay consume oxygen. So we call that process deoxygenation, and global warming is enhancing and spreading deoxygenation, but excess blooms caused by ocean fertilization could also cause loss of oxygen, which is bad for the animals in the water. It also, the same process that decays the algae, releases carbon dioxide, so it could create excess CO2 in the midwater, a process we call ocean acidification. So both of those things could happen in the water column on the way down. With the case of the macroalgae, we are concerned about what happens when it gets to the bottom. Having Huge piles of dead seaweed on the seafloor would basically smother the animals in the deep sea. It could create, again, low oxygen or anoxic conditions. I think a really important aspect of moving forward with climate interventions, such as the ones I've been talking about, is the opportunity to do some thorough integrated science around them to understand where that fixed carbon goes, whether it stays where people would like it to be, and whether they can scale up to make this effective. So there's a really important role for ocean scientists here, and I hope that they get a chance to get involved and help create some coordinated research programs. Oh, gee. I was really fortunate. As a high school student, I had the opportunity to participate in a National Science Foundation program at Humboldt State College one summer. I was only 16. I learned about marine biology and oceanography that summer, and I really became hooked on it. And so, had a lot of great teachers. Had a lot. I also grew up in Los Angeles near the ocean, not too far anyway, and I took the bus down there every day in the summer. So the ocean is such an amazing place. It's such a frontier, as you say. There's still so much to discover. I feel like I'm learning new things all the time.